Hi, today we'll be dividing fractions. Specifically, our objective is to understand why we invert and multiply to divide fractions and why that works. The question is, why don't we just divide? If we have a simple problem, that actually works well. If we have 3/4 divided by 1/4, we can show that using a model. If we have a chocolate bar divided into fourths, and we have 3/4 of that to begin with, and we divide into groups of 1/4. We're going to look at how many groups of 1/4 do we have. There's 1, 2, 3 groups of 1/4, so our answer would be 3. 3 groups of 1/4 in 3/4 of a bar. Now if we have a trickier fractions in our division problem, we run into trouble. For instance, 2/3 divided by 5/8. If we try to show that through a model, we create thirds. It's much more difficult to show 5/8 groups within those two-thirds of the chocolate bar. We get to a lot of division of chocolate that's kind of ugly. So rather than do that, we have a more efficient method, and I'm going to show you why that method actually is division and not multiplication like it seems. We're going to use that same problem, 2/3 divided by 5/8. And the theory here is that we're going to create whole numbers to divide by using common denominators of 1, which is what inverting and multiplying accomplishes. So we're going to have whole numbers to divide. Let's do this by getting rid of these denominators. If we were to ask ourselves how to get rid of thirds, we would multiply everything by 3 to get rid of that denominator of thirds. So we would want to multiply by 3, and we would also have to multiply our other fraction by 3 to keep it balanced in the equation. So if we multiply this by 3, we actually get 6/3 divided by 15/8. And 6/3 we know is 2 wholes, or 6 divided by 3 makes 2 wholes. So we've just created a whole number there by multiplying everything by 3. We could simplify and do that if you're aware and used to doing that. You can simplify 3/3 actually equals 1 and then multiply that by 2. We get 2 wholes. Anyway, we want to create a whole number over here. So what we're going to do is get rid of that denominator by multiplying everything by 8 again. That includes this side, so our whole number will get bigger. This whole number is going to become a 16. Divided by, and then we have 8/8 equals 1 to simplify, which gives us 15 times 1, a whole number. So now we have 16 divided by 15 as our entire problem, which can be written in fraction form, 16 divided by 15, and that's our answer, unless we choose to make a mixed number out of that. Okay, if we write it in the invert and multiply way, we have 2/3 times, and then you invert the fraction, 8/5. Let's show how that relates to this. What we're doing here is multiplying by those denominators, multiplying the numerators by those denominators. Here we have 2 times 8, which is what we achieved here by multiplying that 8 by 2 and getting a 16 whole number. Here we have 3 times 5, which is what we achieved here by multiplying this 3 and having a 15 there. So we are actually cross-multiplying to get that common denominator of 1 and get rid of those denominators altogether. So we have 2 times 8 equals 16 over 3 times 5 equals 15, which is a much quicker, more efficient way to complete this problem. Let's do one more sample problem. Let's try 6/8 divided by 7/9. Okay, again, we're going to want to get rid of those denominators. We're going to multiply everything by 8 here, and everything by 8 on the other side. 6 times 8 is 48/8, which again equals 6 wholes. And then 7 times 8 is 56/9. Okay, we have 6 wholes divided by 56/9. We want to get rid of the ninths. We're going to multiply everything by 9. We have 54 wholes over here. And then I don't want to multiply that out, so I'm going to use the simplification. I have 56 wholes on the other side. So I have 54 divided by 56, which can also be written 54 over 56. And that's divisible by 2. So we're going to take that and divide by 2 and simplify. 7/28. Now, again, if we invert and multiply, let's see how much quicker that tends to be. We're going to invert that fraction, create 9/7, which is what we're doing by multiplying those denominators. We have 6 times 9 is 54. 8 times 7 is 56, and we got there much more quickly. We could still simplify, but a much more efficient method of getting that division done than trying to go through this whole process. Thank you for coming.